Okay, boys and girls, so today we are going to turn to page 101 in our math books, and we are going to work together to complete 1 through 6. So I am going to give you about 30 seconds to grab a pencil and your math book and turn to page 101. Okay, so you should have everything you need. So like I said before, we are on page 101, and we're going to go ahead and look at question 1. So it says, a building has 9 rows of mailboxes. There are 6 mailboxes in each row. How many mailboxes are there? So before we can start answering this question, we need to think about what it is asking. Does it want us to add, subtract, multiply, or divide? So when I am looking at this, right away, I see the clue words 9 rows and then 6 mailboxes in each row. And I know from my teachers over the past couple of weeks, whenever I see information about rows and an item in a row, I know right away that this is going to ask me to do multiplication. So your equation for this would be 9 times 6 equals. But now you have to use whatever multiplication strategy you are comfortable with to solve this problem. 9 times 6. So you could do 9 groups of 6. You could add 9 6 times. You could do skip counting. So I'm going to give you 1 minute to answer this question using whatever strategy you are comfortable with. I am also going to go ahead and give you some choices. So, is the choice 15? Is the choice 48? Or is the best choice 54? Go ahead and take some time to solve this and then write the correct answer on the line. Please begin. Okay, so after doing a strategy, you should have easily looked at these choices and said, well, it's not going to be 15 because that would be the answer if we were adding, and we are not adding here, we are multiplying. And that left 48 and 54. I put 48 down because that was close to what the answer could have been, but after working it out, you should have realized that 9 times 6 equals 54. So go ahead and take some time to make sure you have the right answer written down, and we're going to move on to question number 2. Okay, let's begin. Question 2. Please follow along with your finger under the word tickets. Tickets to a juggling show cost $5 for each adult and $2 for each child. 4 adults and 3 children go to see the show. What is the total cost of their tickets? So I'm going to read that one more time because there is a lot of information going on in this question. Tickets to a juggling show cost $5 for each adult and $2 for each child. 4 adults and 3 children go to see the show. What is the total cost of their tickets? So in this question, there is something called a hidden question, which means you have to answer some information first in order to answer the big question of what is the total cost of the tickets. So I'm going to help you out with this one because this can be really tricky. So the hidden question up here is, well, how much money was it for the children to go and how much money was it for the adults to go? Because we don't know that yet, and we have to know that in order to answer that big question. So because I told you the answer to part A, I'm just going to put an X through it, and I would like you to do the same. So I'm going to come down now to part B. That's where the real magic is. That's the real focus of our work right now. So like we did previously, and I'm sorry it erased, that should have an X through it because I already told you that the hidden question was, how much did it cost for the adults, and how much did it cost for the children to go? So now down here, it says draw bar diagrams for this problem. Show the equations that you used. Boys and girls, you don't technically have to use a bar diagram for this problem unless you are comfortable with it. You may use whatever strategy works for you. So first, let's make like a little chart. Let's figure out how much it costs for just the adults to go. So we're going to break this problem down into the adults and the children. Let's focus on the adults. So it is $5 for each adult, and 4 adults went. So my equation for that would be 4 adults at $5 a piece means that just for the adults to go, it costs $20. Okay, and that's answering that question. Show the equations that you used. But we don't just have adults going to the juggling show. We also have children going to the juggling show. So now I'm going to make another little section of information, and this is for the children. And boys and girls, make sure you are following along with me and you are also writing down this information. I am writing slowly, I am talking slowly to give you that chance to make sure your information is completed. So for the children, you have 3 children going to the show, 3 children because those are my 3 groups, and the children are $2 a piece. So then I do 3 times 2, and you should get, everybody write down your answer. You should have written down 6. 3 groups of 2 or 2 groups of 3 equals 6. So now it's $20 for adults and it's $6 for children. Our hidden questions have been answered, but now we have to answer our huge question, and I'm going to underline it in blue. I'm going to change my color for you. What is the total cost of their tickets? Total cost. I remember that from previous grades that whenever I see total, I'm usually going to be doing some sort of adding. So now I will take $20 and $6. And if I add 20 and 6, I get, I'm going to do my money sign, $26 as your answer. So go ahead and take 30 seconds to make sure you are all caught up on this information. Okay, so we are now moving to the top of the next page, and we are going to be on question number 3. Go ahead and put your finger under the word Mr. Okay, and follow along, please, as I read. Mr. Blonsky wrote 5 equations on the board. Which of the equations did he write correctly? Choose all that apply. I'm going to read it again. Mr. Blonsky wrote 5 equations on the board. Which of the equations did he write correctly? Choose all that apply. So 2 things up here that are really coming out to me are which did he write correctly? You're looking for the right ones. And choose all that apply. That's going to tell my brain that any one that is right, you're going to put a check mark next to. So for this one, you have to look at every single equation to make your decision. You have to use the rules that you have learned about multiplying in order to get this correct. So let's start with the first one. 24 times 0 equals 0. Did Mr. Blonsky write that correctly? You should have said yes. So that one gets either shaded in or a check mark. I'm going to shade it in with this pretty orange color since we're getting close to Halloween. Yes, that is written correctly because there is 24 groups of nothing. That means you have nothing. There's nothing there. And we know a rule. Anytime you multiply a factor times 0, your product is going to be 0. So let's come down and look at the next one. 45 times 1 equals 45. Did he write it correctly? You should have said yes. Yes, he wrote that correctly. We have a rule when we're multiplying with 1, that any time you multiply with 1, it is going to be the other factor as your product answer. And that also means there is 45 groups. 45 groups, 1 in each group. Well, if you added 45, all those ones up, it would equal 45. So that is correct. Let's come down to the third choice. You have 67 times 1 equals 1 times 67. Now, boys and girls, if you have forgotten, this is an example of the commutative property. I like to remind my children that the equal sign is like the peanut butter that's holding your bread together. And when you make a sandwich, you like both of your bread pieces on your sandwich to be the same. So if you have wheat bread on one side, you would want wheat bread on the other side. You want them to match. So is this showing the commutative property correctly? Are the factors on one side the same as the factors on the other? Yes. 67 times 1 equals 1 times 67. Absolutely. So I'm going to go ahead and give you 30 seconds to answer the last two equations. Remember, if they are written correctly, you will color them in. If they are wrong, you will leave them blank. Okay, I think that's about enough time to go over these. 38 times 0 is 38. That should be, left blank. That is not correct. He did not write that correctly. And we should know that because he multiplied with 0. And we know our rule of 0, just like up here, the product would be 0, not 38. So that is wrong. We're going to leave that blank. And then the last choice is 77 plus 1 equals 77. We should know that that's not correct. We know that 77 plus 1 equals 78. So we're going to also leave that one blank. Okay? We are moving on to question number 4 about Mark. So let's begin. Finger under the word Mark as I read. Mark is thinking of a number that is a multiple of 9. Which of the following could be Mark's number? Choose all that apply. I'm going to read it again. Mark is thinking of a number that is a multiple of 9. Which of the following could be Mark's number? Choose all that apply. So in this question, I see multiple of 9. Thinking of a number. Choose all that apply. Those are important pieces of information that I noticed when I was reading this. So in order to answer this, you have to know what a multiple is. A multiple is a number you say when you skip count by a number. In this situation, we are skip counting by 9s. So I'm going to write a 9. That's one way I'm going to keep track of my information. And I am going to keep skip counting by 9. And if I land on a 9, if I land on a number in this area when I'm skip counting by 9s, I will know it is a multiple of 9. I'm going to show you 2 ways to solve this. So this is the first one, starting with 9. And for those of you who are allowed to use a 100s chart, this is a great opportunity for you to take out your 100s chart and put your finger on number 9. So when you are on 9, we are going to skip count 9 places or count on by 9 times. 10, 11, 12, 13, 14, 15, 16, 17, 18. So the next number I land on is 18. I'm going to do that again. I'm at 18, I'm going to add on 9. 19, 20, 21, 22, 23, 24, 25, 26, 27. Very good. And look, I see a 27 over here. So 27 is a multiple of 9. So boys and girls, that is one way you can do this. And obviously, you're going to keep counting. I am only at 27. You want to get all the way up to 81 and see if it matches. I just did 3 as an example, or we would be here all day. The other way you can do this is by setting up your ones and tens column. So for example, I'm going to start with 0, 9. Everybody write that for me. 0, 9. I'm going to increase my tens places by 1. I'm going to put an arrow up. I'm going to decrease my ones place by 1. So what comes after 0? 1. What is 1 less from 9? 8. This is much simpler than that way. What is 1 more from 1? 2. What is 1 less from 8? 7. You see what I'm doing? Do you see how I'm going up? I'm going down. So let's focus on just going up. 3, 4, 5, 6, 7, and we'll stop at 8 to make things pretty easy. And let's go ahead and go down. 9, 8, 7, 6, 5, 4, 3, 2, 1. So now when you go back and look at these numbers, you're not reading them 0, 9, 1, 8, 2, 7. No, 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 no. You're reading them 9, 18, 27, 36, 45, 54, 63, 72, 81. These are the numbers you say, and there's more obviously, when you are saying the multiples of 9. So is 45 in that list? Yes, it is. It is right here. So 45 is a multiple of 9. Is 48 a multiple of 9? Nope. So we leave that blank. Is 67 a multiple of 9? Nope. So we leave that blank. Is 81 a multiple of 9? You betcha. So we fill it in. Boys and girls, please remember, you can only do this trick when you are doing 9s. This is a 9s trick, but you can use skip counting for any number. All right, let's move on. We have 2 left. You guys are doing great. All right, so for number 5, there is something you must know to answer this question. Alex has 5 dimes in his pocket. How much money does Alex have? Let's read it again. Alex has 5 dimes in his pocket. How much money does Alex have? So boys and girls, think to yourself, what do I have to know to answer this question? If you said you have to know how much a dime is worth, you are correct. So a dime is that really tiny coin, and it is worth 10 cents. And this is how I'm going to represent my 10 cents using a decimal that shows $0.10. So Alex has 5 dimes in his pocket. So if we know that, and we can just put a 10 here to make it easier since we really haven't learned much with the decimals yet. If we know that a dime is 10, 1 dime, how much would 5 dimes be? I'm going to give you 1 minute to answer this question. Okay, boys and girls, so the answer to this, how much money does Alex have, is 50 cents. So you could have written it like this, or if you understand the decimal system with dollars and coins, you could have written it like this. And there was many ways that you could have answered this. You could have done 5 times 10. Some of you may have chosen to skip count, and that would have looked like or sounded like, 10, 20, 30, 40, 50. There's many ways you could have solved this. I would not have recommended counting up 10 tally marks for this one. That might have taken you some time. Last one. You guys have made it. Our last one. Give yourself a hand. You did an amazing job. Number 6. Now, in order to know this or answer this, you have to know what that math word is. Choose the greatest product. Product is an answer to a multiplication equation. So in order to get this one correct, you have to solve every single one of these, and whichever one has the largest answer or the largest number, because that is a multiplication word for product, you have it right. So you need to solve all 4 of these equations. And boys and girls, the exciting news is every one of these has a factor that has a rule that is easy. So watch this. I'm going to use hot pink for this one. We know a rule with multiplying with 1. We know a rule with multiplying with 0. We know a rule with multiplying with 2. And we know a rule for multiplying with both 5 and 2. So go ahead. I'm going to clear that so it's not in your way. Go ahead and take a minute to solve all 4 of these equations. Remember, you are doing 9 times 1, 10 times 0, 2 times 3, and 5 times 2. Do not pick an answer yet. You have to do the work first in order to get this correct. Okay, so let's go ahead and start. 9 times 1, 9 groups of 1. So if you have 9 ones, the answer is 9. We should know that, boys and girls. That one's easy. 10 times 0, you have 10 groups of nothing. You don't have anything. The answer is 0. 2 times 3 means that we can either count by 2 3 times, or we can double that 3. 2 times 3 is 6. And then last but not least, we have 5 times 2. You can read that as 5 groups of 2, or you could double that 5 because of the 2, or count by 5 2 times, whatever works for you. The answer is 10. So you have your products, 9, 0, 6, 10. Which one is the greatest one? Obviously 10. We know that 10 is the biggest number. Very good, boys and girls. So now here is your job. You did a great job following along with me. You are now to go onto Seesaw. And when you are on Seesaw, you are going to find the topic to review. And it is going over questions 7 through 13. I'm going to show you really quick what that looks like. So if I go here to the next page, all you're going to do on Seesaw is answer these questions, but on Seesaw, because I'm reading them to you and I'm walking you through them. And that's really going to help you prepare for the assessment next week. All right, boys and girls, I hope you enjoyed this video. Good luck on Seesaw and have fun.